Now, I'm interested in this surface over here. Okay. And this surface, to get to that surface, I need to rotate this in a clockwise direction by 14.4 degrees, right? So on Mohr circle is 28.8. So the yellow line corresponds to this surface that we are talking about. Now, if you look at the shear is going in, the element will be rotating what direction? Anti-clockwise direction. Okay. So your shear stress has two possibilities. Is it coming down? Dun, 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 dun. Is it going up? Dun, 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 dun. It is based on the rotation of the what? Element. So if you look down here, the element is going clockwise or anti-clockwise? Anti-clockwise. So for it to do anti-clockwise, it has to look like this. And this is where you have your 570.635 megapascal. Are we clear? It depends on the rotation of the what? Of the element. Now let's look at the other point now. Okay, let's look at the pink one now. Pink surface. At the pink surface, it corresponds to this dot over here. Okay, and we know the element on the top is going to rotate what direction? Clockwise direction in terms of shear. Yes or no? In terms of shear, the element at the top have to rotate what? Clockwise. To go clockwise, you only have one orientation to go, and it is this orientation that you have to go. So now you know how to translate from Mohr circle to the element in terms of normal stresses and what? Shear stresses. Are we clear? Okay. We are going to do another example, okay, so that you can solidify the knowledge. Okay, this is easy. Okay, this is straightforward. This is the basics. Okay, this is the basics. Okay, now solve this using Mohr circle. Why I push for Mohr circle? Because you could visualize. You can don't use Mohr circle, and I'll show you the textbook. And good luck. Okay, you can use the textbook. And if you were to look at the textbook where we are now, stress and strain and transformation, I used to teach this, but I realized that, yeah, forget it. We have to write all this formula out. Okay. And the outcome is still there. Look at this. Holy crap. Can you see what you're looking at? Don't waste your time. Directly linked to the what? To the circles. Are we clear? Okay, we don't have time for this. This is all. In the end, it's the same formula that we use, okay? It's all the same, but yeah, good luck. Okay, don't bother. Right. We are going to do another example, and this example is more difficult. It looks innocent, but not so innocent. Like my term test question. It looks innocent, but not so innocent. But it's possible, okay? For your info, some of you have my past year question. I don't repeat my question. Okay? How many of you have my past year question and solution? Okay? Don't memorize them. Not helping you at all. Okay? I'm serious. Right. So watch what they are asking us now, okay? Determine the equivalent state of the stress for an element that has rotated 60 degrees counterclockwise from the element shown. So this thing is going to rotate 60 degrees counterclockwise. Okay. Go and sketch our transformation. This is different now, okay? Okay. This is your X, and this is your Y. So the 60 degrees, okay, so like before, okay, don't, wait, let me, okay, like before, you label this as your point X. You label this as your point Y, okay? Okay. Then I'm going to start rotating 60 degrees. I'm going to draw the plane that's rotated 60 degrees in a counterclockwise orientation. Okay. How I get this 60 degrees is I rotate from here counterclockwise 60 degrees. Okay. So when you start from 60, from Y, I hope you all will do the normal practice and call this line Y60. Okay, because it's from Y. Now from X, what is the angle? Anyone? If we are going to rotate from X, then you have to rotate how many degrees? This is how many degrees? 30 degrees. When that's the case, if you are going to rotate from X, you are going to call this X30. Be clear? You rotate from Y, call it Y60. You can rotate from X, you call it X30. Whether is it Y60, X30, the normal and shearing stress are the same. Are we clear? Whether you use Y60, X30, the answer will have to be the same. If it's different, something is wrong. Okay, if it's different, something is wrong. Okay. So by looking at this element, okay, do not feel overwhelmed. It's just an element. Okay. Most the elements are afraid of you. So we know that stress X is equal to minus 560 megapascal. Okay. And stress Y is equal to 250 megapascal. And we also know that the shear XY is equal to the shear YX, and this is equal to minus 400 megapascal. Okay, let's take a break. I have something to confess. I did something so wrong that security is after me now. Now, security don't know it's me, but I feel so bad. Okay, it's the drawing that I drew on the wall. So, as a teacher, as your mentor, I have to set a good example. Okay, I have to, like, I told my wife about it and I told my daughter about it. My daughter didn't. Okay, so I have to clean up. I'm clear. Okay, I'm not told the security yet. Okay, but it's me. Okay. So what I did on Friday, I did some experiment. Any idea what experiment I did? How to clean permanent marker of the brick wall. And I found a solution. High alcohol Chinese wine, 60%. Okay. So if tomorrow, if you see me cleaning the wall, don't laugh. But if you want to drink 60% alcohol, feel free. Hey, no. Moral term test, yeah. No drinking, yeah. Tomorrow drink, I can tell you, IXX is good to IYY is good to IXX. Okay. Okay, I'm better now. Okay. Don't hide, okay? Like when you do something wrong, make it right, okay? And I think I have to tell security. If they want to deduct my paycheck, go for it, But and today I lost a lot on in the stock market, freaking Donald Trump. But anyway. Right. Close to 60,000 today. Bloody hell. But anyway, life goes on. Okay. Where am I now? Losing 60. Oh, it's okay. It's okay. Let's go on. Focus. So now we are. Oh, crap. It's recorded. It's okay. I know you guys will not betray me. Some of you will kill me if I'm not looking. So now we start sketching Mohr circle. Okay, we start sketching Mohr circle. And as I say, I don't know, but I'm going to start from minus 700. Minus 200, 100, 0, 100, 200, 300, 400, 500, 600. I think 600 is more than enough. So this is normal stress. Okay, make sure the right. Make sure the scales are okay. If not, I told you, right? You get more over, right? Okay. You should have seen my daughter pointing finger at me, She said in her school, no one dare to draw on the wall. And it's so embarrassing. But it's okay, my fault. So the shear stress over here rotate clockwise, down here rotate anti-clockwise. We do the same. 100, 200, 100. Okay. Again, the same. Right. So we know that at one stress state, we are at 560. So this is 550. This is about 560. And the other state, we're at 250. 50. And then we have the shear, which is running at 400. For the shear, you have to go for the positive 400. And you have to go for the negative 400. Okay. So we are going to label this. This is for stress X. This is for stress Y. Okay. And then if you look at stress X, okay, 560, element going to rotate clockwise or anti-clockwise? At 560. Anyone? So you look at 560 at X, is going to rotate what direction? Clockwise direction. Okay. And then we know the Y, yes. So if you look at this arrow that's coming down in terms of shear, right? If you put your finger in the center, rotate clockwise. We are looking at shear, right? Over here, the element rotate clockwise. Over here, the element rotate anti-clockwise. right? Okay. And then at Y, right, based on the shear, right, the shear is that is going to rotate in what direction? Clockwise direction. We good? This is important, okay? So from here, we draw a straight line. Upon drawing a straight line, the process is always the same, okay? What is this process? The first thing that we're going to do, right? The process is already, if you don't believe me, you look at last week's notes, okay? We are going to calculate the center of what? Of circle. And the center of circle is known as our stress average. So you know by looking at this, center of the circle is stress X plus by stress Y divided by 2. If you don't write the formula, I'm also fine with it, okay? So it's minus 560 plus by 250 divide by what? Divide by 2, okay? Remember, stresses are vectors, okay? So minus 560 plus by 250, okay? And then we divide by 2. It's minus 155 megapascal. So when we eyeball this, yeah, it's about minus 155. So from here, you take your green. You don't take your green, you just draw a line where it intersect over here. This is your 155, and this is where it is your O. Okay. Immediately from here, we can calculate our radius of the circle, like what I did last week.